Dev Tyagi.
On behalf of SPE IIT ISM Student Chapter, would like to welcome Mr. Sharad Agarwal sir in the second webinar under the SPE Winter School series. This Zoom meet will be of 40 minutes. After that, a new link will be sent in the chat box.
Now, we introduce to you all Mr. Sharad Agarwal sir, who has worked as ISDS, Integrated Services Drilling Supervision, Senior Well Engineer with Transocean, Mumbai on the Jacob rig and drill ship, and he has also worked as night drilling supervisor with Deep Industries. He holds a master's degree in petroleum engineering with more than 13 years of drilling operational and training experience. He completed his NEBOSH International General Certificate in Occupational Health and Safety. Moreover, Sir is also an IADC Civil Shop instructor in fields like drilling, workover, coil tubing, and safety.
Lastly, I welcome everyone who is participating in this program through the designated web platform. I firmly believe that we would be enlightened much over the subject after hearing thoughts of Sir, provoking lecture on today's topic, that is well control. I welcome you all again on behalf of SPE IIT ISM Student Chapter for attending this program to make it a grand success.
Before starting with today's webinar, I would like to request all attendees to please keep their mics muted for the smooth conduct of the session. Attendees can write down their queries in the chat box. We'll be having a separate Q&A session for that. Sir, we hand over this virtual platform to you now. You may start this lesson of Winter School.
Okay, thank you so much. Thank you, Dev Tyagi. Thank you, Anshu Ranjan. I must say it was a revision for my whatever education I've done, my experiences. Thank you so much for reminding me that I'm very qualified. Okay, very nice. Very nice. Thank you for inviting me for this class. Okay, almost my introduction was given by Dev and Anshu. Okay, so let me directly come to the topic about well control. So, my dear students, well control is very important topic. Okay, anybody who is associated with oil and gas industry, whether you are working on rig or whether you are not working on rig, okay, it is very important. Okay, everybody should have understanding of well control. Okay, so guys, I cannot share my screen. Can you help me to share the screen? You have to make me host. Okay. Thank you so much. Okay. So, come on, tell me, what do you understand by well control? Message me in chat box. Message me in chat box. When we say well control, what do you mean by that? What do you understand by well control? Come on, I want everyone to be very active in this class. Okay. This is not a generalized topic. It is very important topic. Okay, oil and gas industry is very serious about well control and safety. Okay, come on, message me in chat box. Yes, message me. Who knows what is well control? Yes, tell me. What do you understand by well control? Let me see who is very active in my class. I hope you guys can use chat box, okay, to study the unwanted behavior of well control of unwanted fluid coming out, preventing undesired fluid influx. Okay. Any more planning about the different aspects of well? No, guys. Controlling every undesirable activity from subsurface. No. What are you controlling? Okay. Yes, it is the process of maintaining pressure inside the well. Okay. Preventing blowouts. Okay. Guys, everyone is very close. Okay. Everyone is very close. Okay. But well control is like you have to be very, you have to be correct. Okay. So well control is you are controlling your well. Okay. By maintaining hydrostatic pressure more than formation pressure. Okay, you are preventing, you are restricting the entry of formation fluid into wellbore. Okay, you are restricting, okay, the entry of formation fluid. Guys, it is very important. Okay, so if during any interview, if somebody will ask you, okay, yes, Dave, you have attended well control. Come on, tell me what well control is. So well control is you are maintaining hydrostatic pressure slightly greater than formation pressure so that formation fluid doesn't enter the wellbore. Okay, it is very important, guys. Okay, you have to always maintain hydrostatic pressure. Okay, so when I say hydrostatic pressure, what do you mean by hydrostatic pressure? Can anyone message me in chat box? Let me see. Let me see. Okay, so till now Dev Tyagi is very active in my class. Now let me see. Come on, tell me. Yes, very good. Oh, what's the name? The Terminator. Who is this Terminator in my class? The pressure exerted by fluid. Yes, Supriya, correct. Anshu, correct. Pressure due to the fluid column. Yes. Okay, so I see everyone, I mean, still you guys partly knows what hydrostatic pressure is. Now let me tell you very clearly, hydrostatic pressure, okay guys, listen to me, okay, even a single word in well control is very important. So hydrostatic pressure is the pressure exerted by static column of fluid. Okay, so when your mud is at rest, when I say mud is at rest, means you are not circulating. Okay, you are not circulating. Now suppose this is my wellbore. Suppose this is my wellbore and I have fluid, I have mud in this well. Okay, so when this mud is static in the well, you are not circulating. The pressure exerted by the fluid at the bottom of the well is called as hydrostatic pressure. You are not circulating. Okay, so that is called as hydrostatic pressure. And when you are circulating, when your pumps, when pumps are on, the pressure is bottom hole circulating pressure. Okay, so these are the two different terms, hydrostatic pressure. Okay, yeah, what is pressure? Come on, tell me. I hope you guys know what is pressure. What is pressure? I think everyone should answer my question. What is pressure? Come on. Pressure is force per unit area. Yes, so pressure is force exerted on a unit area. Yeah. And the units is PSI. What is PSI? Pounds per square inch. PSI is pounds per square inch. Okay. So, to start. So, let us start with basics of well control. Okay. So, why well control? I hope you guys can see my screen. Huh? Okay, so why well control is important? Okay, well control is very important. If there is any well control event, if there is any well control event on rig, so what are the negative impacts of well control? When I say well control event, what is well control event? Well control event I consider here as a blowout or kick. Okay. Okay, so when I say blowout or kick, what do you mean by blowout or kick? What is difference between blowout and what is difference between blowout and kick, guys? Yes, message me, guys. Message me in chat box. When I say blowout and kick, what is difference between blowout and kick? Okay. Yes, Supriya, very active candidate in my class. Dave, very good. So what is difference between blowout and kick? Kick is controllable. Okay. Blowout is uncontrolled. No. Very good, Rishabh. Very good, Rishabh Kumar. So is kick. Rishabh has given me a right answer. Okay, so kick is entry of formation fluid in the wellbore. Okay, when your formation fluid, when formation fluid is in the well, it is called as kick. And when this formation fluids come to the surface, it is called as blowout. Okay, you can control kick as well as you can control blowout. Okay, there is no problem in that. Kick is an entry of formation fluid in the wellbore and blowout is at the surface. Very good, Rishabh. Okay. So if there is any well-controlled event, okay, so it will impact many areas, like it will impact physical injury, psychological impact, loss of job, driller, tool pusher, rig managers, assistant drillers, they can lose their job, damage to the environment, okay, damage to the environment, which is that incident? Yeah, Gulf of Mexico. You know, guys, Gulf of Mexico, sea animals, they died. Okay. The environment was badly affected. Damage to local or regional society and damage to company reputation. Company reputation will be badly affected. Due to that Gulf of Mexico incident, BP was fined by US government authorities millions of dollars, and it was banned for 5 years to drill any well in that area. Okay. So why we must train and assess, why this well control training is important? Key personnel means anybody who is working on rig or anybody who is working in oil and gas industry must do well control training. Okay, so key personnel need to be trained and assessed in their well control responsibility for number of reasons. Now you guys are doing this course. Okay, of course it's a short course. You guys are doing this course, so it means that you are aware so what to do in case of kick and what we have to do in case of blowout. Okay, and apart from that, you also know how to detect a kick. Okay, it is very important. So this training, okay, in this well control training, everybody who is attending, it is not only for freshers. Okay, everybody who is working in oil and gas industry should do this course every 2 years so that you can review your well control knowledge. Okay, so in well control training, we all teach so they are competent and able to perform their well-controlled duties correctly and when required. Okay, so it is very important that driller, assistant driller, tool pusher, rig managers, they know how to detect a kick, what are the kick indicators, what are the kick warning signs. So their work colleagues, employers, and clients can rely on them to be able to respond correctly and appropriately. Okay, so anybody has this well control certificate, whether it is from IADC or IWCF, okay, it proves that you have knowledge of well control and your colleagues, your employers, your clients rely on you that, okay, Mr. Dev, Mr. Anshu, Mr. Ravi, Mr. Rishabh, they have done this basic, they have the basic knowledge of well control and we can rely on them because they hold valid IADC or IWCF certificate. So employers can rely on the qualification of new hire personnel to mean that a known training and an assessment standard has been met. Okay, so IADC and IWCF, these two are international organizational bodies. Okay, they approve some institutes. Okay, where you can go and do this well control training. It's usually for 5 days. Okay, you do this well control training. Complete exams as per IADC and IWCF standards, and if you pass, you get your certificates. To demonstrate to industry and society at large that personnel are trained and competent to government that we are in control. Okay, so it is so Indian government or Middle East government authorities, okay, they have some restrictions on drilling companies that, okay, if you are drilling in this location, all your employees should have IEDC or IWCF certificate. Okay. So let us start with well control. Okay, so what is hydrostatic pressure? I told you we use mud. We use mud to control. What are the functions of mud? Yes, to exert some hydrostatic pressure, to lift cuttings, mud cake, lubricant. Okay, so there are different functions of mud, but in well control, mud is exerting some pressure at the bottom of the well. Mud is exerting some pressure at the bottom of the well. So this pressure, when the mud is at static, is called as hydrostatic pressure. Okay. So what is hydrostatic pressure? Hydrostatic pressure is the pressure exerted by a column of fluid at rest. Okay, this is very important. So when your mud is at rest, the pressure exerted by mud at the bottom of the well is called as hydrostatic pressure. And this pressure is calculated using the formula hydrostatic pressure is equal to mud weight into constant 0.052 into true vertical depth. Okay, so hydrostatic pressure is the pressure exerted by column of fluid at rest and is calculated by multiplying the density gradient of fluid by the true vertical depth at which the pressure is being measured. Okay, so this is the formula to calculate hydrostatic pressure. Hydrostatic pressure is mud weight into 0.052. 0.052 is constant. TVD is true vertical depth, which is in feet. Okay, now what is true vertical depth? Now suppose this is your rig. Guys, my drawing is very bad. Okay, so please cooperate with me in drawing. Okay, so this is your rig and you're drilling. First, you're drilling a vertical well and then you're drilling a directional well. Okay, so it's like L-shaped well. Okay, now, so this total height, okay, this vertical height is 8,000 feet. Okay, the vertical height. Okay, I'm talking about vertical height, and this total length is, suppose it is 9,200 feet. Okay, so the total length of well is called as measured depth. Okay, or something. So the total length of well is called as measured depth, and the vertical height is true vertical depth. Okay, so please keep it in mind that while you are calculating pressure, whether it is hydrostatic pressure, bottom hole pressure, any pressure, you have to consider TVD. Okay, in exams, sometimes they confuse you that, okay, whether to, sometimes they ask you to calculate hydrostatic pressure and then they'll give you TVD and MD both. Okay, so don't get confused. So if they're asking you to calculate pressure, then you have to consider TVD. And if they are asking you to calculate strokes required for circulation, time required for circulation, well volume, okay, so then you have to consider measured depth. Okay, you have to consider total length of well. Okay, so guys, please don't get confused. Okay, so if you are calculating pressure, please take TVD, and if you are calculating strokes, time, and well volume, then you have to consider measured depth. Okay, so MWD is mud weight. Mud weight is in PPG. What is PPG? Yes, message me in chat box. What is PPG? Where is my Rishabh? Rishabh Kumar. What is PPG? Come on. Pounds. Whoa, whoa, whoa. Very nice, very nice. Okay, so yes, correct. ppg is pounds per gallon. Very good. Okay, come on, now do this calculation. If mud weight, let me see. Let me stop this. Okay, so we have seen the formula for hydrostatic pressure is mud weight into 0.052 into TBD. Okay. Now suppose mud weight is 10 ppg and TBD is 10,000 feet. So what is hydrostatic pressure? Yes, message me in chat box. Let me see. Yes, very good. It's 5,200 psi. Very good. It is 5,200 psi. Yes, very good, guys. So units is very, very important. Please use units everywhere. Okay. So if you are working on rig, okay, units is very, very important, guys. Okay. So now keeping constant mud weight as 10 ppg, if I change my TBD to 1,000 feet, if I change my TBD to 1,000 feet, then what is my hydrostatic pressure? Guys, TBD is 1,000 feet. It is not 1 lakh feet. Yes, correct. It's 520 psi. What happened to Terminator? You are really Terminator, huh? It's 520 psi. Okay, now if I change my TBD to 10 feet, if I change my TBD to 10 feet, then what is my hydrostatic pressure? 10 feet, yeah. 5.2. It's 5.2 psi. Okay, if I change my TBD to 1 feet, if I change my TBD to 1 feet, then what is hydrostatic pressure? 0.52. Very good. Okay, so if TBD is 1 feet, listen to me, everyone. If TBD is 1 feet, okay, then it is called as pressure gradient. It is called as pressure gradient. So what is pressure gradient? Okay, so let us see. So pressure gradient, okay, pressure gradient for mud is the pressure exerted by column of fluid over 1 feet and is expressed in psi per feet. Okay, so this is pressure gradient is in psi per feet. Okay, that you are measuring the pressure on 1 feet of column. Okay, and the formula for calculating pressure gradient for drilling fluid is mud weight into 0.052. So sometimes in exam they'll give you mud weight and then they will ask you to calculate pressure gradient. Okay, so what is the formula to calculate pressure gradient? Mud weight into 0.052. Sometimes in exam they'll give you pressure gradient and then they will ask you to calculate mud weight. Then how you will do? Mud weight is equal to pressure gradient divided by 0.052. Okay, so please write down these two formulas. Please write down these two formulas, guys. I will get some new breakdown.
So the link for the new meeting is in the chat box. So once this meeting gets over, everyone please join through that link.
Okay, no problem. So guys, come on, do this. If mud weight is 15.5 ppg, if mud weight is 15.5 ppg, then what is my pressure gradient? Come on, message me in chat box. If mud weight is 15.5 ppg, what is the pressure gradient? Please write down with units. Please write down with units. Calculate pressure gradient. Yes, Nitesh, very good. It is 0.806 psi per feet. Very good, guys. Very good. I'm really happy that you guys are learning. Okay. So this means that 15.5 ppg mud, okay, 15.5 ppg mud exerts 0.806 psi pressure per feet. Okay. Now, if my pressure gradient, come on, listen to me. If my pressure gradient
Sir, you may start with your presentation.
Yeah, no problem. Thank you so much. Okay, so yeah. Okay, guys, so we were learning about pressure gradient. Okay, come on. So if pressure gradient is 0.44 psi per feet, then calculate mud weight. Come on, tell me your answer, guys. If pressure gradient is 0.44 psi per feet, yes. So what is your mud weight? We have already discussed. Yes, very good, Anshu. So it is 8.46 ppg. Okay, 8.46 ppg. Excellent, excellent work, guys. Very good. I'm so happy you guys are learning. Okay, so understood? So now we will. Yeah. Okay. So now we will learn types of well control. Types of well control. Okay. Now, types of well control means what are the different types of well control? How do you control well? Okay, so number one is your primary well control. Two is secondary well control. And three is tertiary well control. Okay, so it's primary, secondary, and tertiary. Okay. So what is primary well control? Can anyone tell me? How do you control your formation fluid from entering? How do you control? How do you control your formation fluid from entering the wellbore? Primary well control. How? By mud. Yes, very good, Nitesh. By maintaining hydrostatic pressure. By maintaining hydrostatic pressure. So mud, you're using mud to exert hydrostatic pressure at the bottom. Okay. So mud is your primary well control. Mud is your primary well control. Now, if your primary well control fails, okay, then what is secondary well control? Very good, Nitesh. What is secondary well control? If your primary well control fails, formation fluid enters the wellbore. How will you control your well then? Formation fluid. Yes, very good, Nitesh. Okay, so you are using your BOP. Yes, Sandeep, very good. Yes, Divesh. So you are using your BOP. Okay, you are using BOP. Okay, so BOP is your secondary well control. BOP is secondary well control. Okay, so which part of BOP you will close first? Which part of BOP you will close first? You know, right? This is annular BOP. Then you have pipe ram, upper pipe ram. Then you have blind ram. Then you have shear ram, blind ram, lower pipe ram. Okay. So which part of BOP you will close first? Come on, tell me. Which part of BOP you will close first? Whoa. Very good, Nitesh, Shiksha, very nice. So you will close annular BOP. Yes, Shiksha, come on, tell me why do you choose to close annular BOP first? Why do you choose to close annular BOP first? Come on, tell me. Why do you choose to close annular BOP first? Why not pipe ram? Why not blind ram? Why we have to close annular BOP first? Your answer is right. We have to always, it is as per API recommendation, we have to always close annular BOP first. But why? Come on. No. Kick always enters the annulus. Kick always enters the annulus. And these pipes, okay, all rams, they close annular only. They close annulus. But annular BOP is different. We close annular BOP because annular BOP, okay, which is at the top. This one. You see, annular BOP can close on any size of tubular. Okay, so whether you have drill pipe, drill collar, okay, so we can close annular BOP can be closed on any size of tubular. Okay, so what is tertiary well control? Come on, tell me, what is tertiary well control? What is tertiary well control? Shear rams. Tertiary well control is use of shear rams. Okay, you see at the bottom of the not bottom. Okay, second rams. These are shear rams. Okay, these are shear rams. Now what they do, if your annular BOP fails, if annular BOP fails to close the BOP, okay, then you use shear rams. Shear rams will cut the pipe and close the well. Shear rams cut the pipe and close the well. Okay, so this is what happened in Gulf of Mexico. Primary barrier failed, mud failed, formation fluid has entered the wellbore. Secondary barrier BOP, annular BOP failed. Tertiary rams, shear rams, they have also failed and there was a blowout. Okay, so let us watch that video, guys. You'll understand more clearly. Any questions till now? Anyone? Any questions? Please message me in chat box. No questions. Okay, so let us watch Deep Water Horizon, not movie, of course. Let us watch that incident.
April 20th, 2010. 11 workers died and 17 were seriously injured by an explosion on the Deepwater Horizon, an offshore drilling rig located approximately 50 miles off the coast of Louisiana. The rig burned for 2 days, eventually sinking and triggering the largest oil spill in U.S. history.
Okay, guys, 11 people died and many more were injured. And see the sea animals. See the condition of sea animals. See the condition of sea. Okay, very, very, very disappointing,
as
guys.
oil and gas spewed up from the sea floor. The Deepwater Horizon had drilling oil wells.
See, guys, birds, animals, sea animals.
In 5,000 feet of water.
See the conditions, see the water, all oil everywhere, mud, oil-based mud everywhere.
In an area of the Gulf of Mexico known as the Macondo Prospect. In 2010, the CSB launched an investigation to examine the technical, organizational, and regulatory factors that contributed to the accident. During the investigation, the CSB made new findings about why a key piece of safety equipment, the Deepwater Horizon's blowout preventer, failed to seal the well during the emergency. These new findings help explain why the accident was so devastating. And the CSB cautioned that other blowout preventers currently in use could fail in similar ways. Drilling an offshore well involves creating a pathway between the drilling rig and oil and gas reservoirs trapped beneath the sea floor. A deep hole, or wellbore, is drilled through layers of subsea rock.
So guys, you have to keep in mind that formation fluid will enter only annulus. Formation fluid will never enter the drill string because we have a port valve, that is non-return valve, one-way valve near the bit. Okay, we have non-return valve near the bit. If we don't have non-return valve near the bit, then there is a possibility that the formation fluid will enter the drill pipe, drill string. Okay, but most of the time formation fluid will enter only annulus.
Sediment. These rocky layers can contain trapped water, crude oil, and natural gas under pressure. An unplanned flow of these well fluids into the wellbore, known in the industry as a kick, can be dangerous. Without careful management, a kick can lead to a blowout, the uncontrolled release of flammable oil and gas from the well. A blowout can be catastrophic, since oil and gas reaching the drilling rig can quickly find an ignition source, leading to a fire or explosion, endangering the lives of the drilling crew. To prevent kicks, drillers pump a dense slurry called drilling mud into the well, creating a barrier between the undersea oil and gas and the piping leads to the rig. If the mud barrier fails or is somehow removed, the safety of the drilling crew depends on a critical piece of equipment located on the sea floor called the blowout preventer, or BOP. The BOP is a complex electrically and hydraulically powered device that is essential for controlling the well. And in an emergency.
So guys, these are rams. Okay, these are rams. This is our drill string, drill pipe. Okay, these are rams. So as I said, we have different types of rams. One is annular BOP, pipe ram, blind ram, shear ram.
Situation, preventing a disaster on the platform high above on the sea surface. The BOP is connected to the rig by a large diameter pipe called a riser. If a kick occurs, the blowout preventer is designed to prevent flammable oil and gas from traveling up the riser to the drilling rig. This is done by sealing the area around the drill pipe, known as the annular space. To do this, the crew can manually close pipe rams and donut shape.
So guys, this is how we close rams. Okay, it will close around the pipe and it will stop flow of fluid to surface through annulus. Okay.
Rubber devices known as annular preventers. If those devices should fail to work, the last resort is a pair of sharp metal blades which form a blind shear ram.
So this is shear ram, guys. Shear ram will cut the pipe and seal the hole.
And to cut the drill pipe and seal the well. The blind shear ram can be activated manually or by automated emergency.
So this is the tertiary well control, last part of well control, only in case of emergency, where we cut the pipe and seal the hole.
Systems. At approximately 8:45 p.m. on April 20th, 2010, a kick occurred in the Macondo well. Oil and gas entered.
So it's approximately 8:42 p.m. Okay, kick occurred. Driller detected the kick, but it was too late. Driller detected the kick, it was too late. He tried to close annular BOP, but BOP failed. Then he tried to close shear ram, even shear ram failed. Now why? Let us see.
The wellbore undetected, eventually passing above the blowout preventer and traveling quickly up the riser toward the deepwater horizon and the 126 people on board. Just after 9:40 p.m., drilling mud, forced upwards by the rising oil and gas, suddenly blew out onto the rig. Crew members responded by closing the upper annular preventer in the BOP. However, this did not seal the well as intended, and flammable oil and gas continued to flow into the.
See, annular BOP failed to control the flow of formation fluid to surface.
The riser toward the rig. Next, the crew closed a pipe ram. This successfully closed the annular space and sealed the well. But tragically, this proved to be only a temporary fix. Oil and gas that were already above the pipe ram continued to flow inexorably toward the deepwater horizon. As the oil and gas escaped the riser onto the rig, the pressure dropped in the annular space above the pipe ram. But at the same time, the pressure in the drill pipe climbed substantially. The drill pipe was closed at the top, but oil and gas continued to flow in from the reservoir below. After extensive analysis, the CSB concluded that this large difference in pressure likely caused the drill pipe to buckle.
Okay, this is the important reason, guys. Because of the large differential pressure in the pipe and in the annulus, okay, this pipe buckled and driller even closed shear ram. So shear ram also it was not possible, okay, because of the buckling of drill pipe. It was not able to shear the pipe and close the well. Let us see in this video.
Actually bending the pipe off center inside the blowout preventer. The buckling pushed sections of the drill pipe outside of the reach of the blind shear ram blades. This would eventually prove to be catastrophic. At approximately 9:49 p.m., the flammable hydrocarbons found an ignition source. First explosions shook the deepwater horizon. With the drill pipe buckled, the explosion and subsequent loss of electrical and hydraulic power from the rig likely activated an automated system on the blowout preventer known as the AMF deadman, which closes the blind shear ram.
So guys, you understood this, the reason behind Gulf of Mexico incident. Okay, so guys, this is very, very important. Well control is very, very important, that you should detect kick on the right time. Okay, and you should always properly maintain your equipments. Okay, it is always recommended that these pressure testing equipment should be pressure tested and function tested every 14 days. As per API recommendation, all the pressure testing equipment should be pressure tested and function tested every 14 days. Okay, sometimes there is some time pressure from operator side company, so usually they do it in 30 days. Okay, so this was also the second reason that the equipments were not properly pressure tested. Okay, so let us continue. Any questions, anyone? No. Okay, so we have seen types of well control: primary well control, secondary well control, and tertiary well control. Okay, so in this video we have seen that The drill pipe, okay, so there is a question from Abhishek that explain the buckle of pipe. Okay, so the pipe in the BOP, it got buckled. Okay, why it got buckled? Okay, because of high pressure difference in the pipe and around the pipe, it got buckled and it got off-centered from the shear ram. So that is the reason shear ram did not work properly. Okay, if if the pipe was in center and shear ram was closed properly, then there would have not been such a big, huge disaster. Okay. So, okay, Abhishek, thank you so much, dear. Okay, so we have seen types of well control: primary well control, secondary well control, and tertiary well control. In fact, we have seen the example in Gulf of Mexico. Your primary well control mud failed, so the kick entered. Secondary well control annular BOP, it failed, so that is why we use shear ram. Shear ram also failed, and there was a blowout. Okay, so what you do? So if primary well control failed, secondary well control failed, tertiary well control failed, what you will do in this situation? How will you control? How will you control this blowout, fire, and what else? Big disaster. How will you control? Run away from rig, yes. Himanshu. Yes, you are evacuating, you evacuated, everything is done. Now there is a blood, there is a fire. Yes, Nitesh, very good. You are one of the genius candidate. Okay, so you will go for relief well. Okay, you will go for relief well. Now, what is relief well? Okay, now suppose this is your rig. You have drilled well and you have a blowout here. Fire everywhere. All disaster. Okay, so what you will do? You will drill a nearby well. You'll drill a nearby well and you will try to control the pressure from here by injecting some chemicals, lowering the formation pressure. You will try to control this well. So this is called as relief well. Okay. Very good, Nitesh. Looks like you have attended well control before, huh? Okay. Understood, guys? Any questions, anyone? So now we'll see different types of balances. Okay. Number one, overbalanced well. Number two, underbalanced well. Number three, balanced well. Okay. So what is overbalanced well? Overbalanced well is when your hydrostatic pressure is greater than formation pressure. Yes. So when hydrostatic pressure is greater than formation pressure, the well is said to be overbalanced. Underbalance is when hydrostatic pressure is less than formation pressure. When hydrostatic pressure is less than formation pressure, then the well is said to be underbalanced. And balanced is hydrostatic pressure is equal to formation pressure. Okay. Hydrostatic pressure is equal to formation pressure, then the well is said to be balanced. Okay. It is always recommended that you keep your well overbalanced, that is hydrostatic pressure, slightly greater than formation pressure, so that you can drill properly. Okay. So okay, let us do one numerical. Now, suppose your TVD is 9,500 feet. Mud weight is 9.5 ppg, and formation pressure gradient is 0.52 psi per feet. Okay. So tell me whether well is overbalanced, underbalanced, or balanced. Calculate hydrostatic pressure, calculate formation pressure, and check. They've given you TVD, mud weight, and formation pressure gradient. Okay. Tell me whether well is overbalanced, underbalanced, or balanced. Yes, very good. So well is underbalanced. So how you will do? First, you will calculate your hydrostatic pressure. So hydrostatic pressure is mud weight 9.5 into 0.052 to 9,500. So it is 4693 psi is your hydrostatic pressure, and formation pressure is 0.52 to 9,500. 4 940 psi. Okay, so your formation pressure is more than hydrostatic pressure, so well is underbalanced. Okay, very good. So now we'll learn about types of pressures. Number one is your abnormal formation pressure. Abnormal formation pressure. We have normal formation pressure, and we have subnormal formation pressure. Okay, so abnormal formation is if the formation pressure gradient is more than 0.465 psi per feet. Okay, so if the formation pressure gradient is more than 0.465 psi per feet, it is said to be abnormal formation pressure zone. Okay, and most of the kick will occur in abnormal formation pressure zone. Okay, normal formation pressure is, so if the pressure gradient is more than 0.4, sorry, it is more than 0.433 psi per feet, but it is less than 0.465 psi per feet. Okay, then it is said to be abnormal formation pressure zone. Okay, and subnormal pressure is if formation pressure gradient is less than this is, it comes here. Okay, it's more than this but less than this. Okay, so here if it is less than 0.433 psi per feet. Okay, guys, so please understand this. Very, very important, whether you're doing your introductory level, driller level, or supervisory level, this you have to know. So what is 0.465 psi per feet? It is the pressure gradient of seawater. Okay, 0.465 psi per feet is nothing but the pressure gradient of seawater. So if formation pressure gradient is more than 0.465 psi per feet, then it is abnormal formation pressure zone. And if the pressure gradient is between 0.433 and 0.465, then it is said to be normal pressure zone. And subnormal pressure zone is, so if it is less than 0.433. So what happens in subnormal? Mostly loss circulation. Okay, loss circulation will occur in subnormal pressure zone. Okay. Any questions, anyone? I think that it will finish in 2 minutes, huh?
Yes, sir.
So you wanted me to conduct for 1.5 hours, no? You want me to continue or stop? So it's like
So you can continue with your presentation.
Okay, we'll continue for 15 minutes more then. I don't know what plans you guys have. Okay. So guys, understood. So we have discussed very important topics. Okay, we have discussed about hydrostatic pressure, formation pressure, pressure gradient, and we have also seen Gulf of Mexico, that why did the team failed? Okay, why did the team failed? Okay, to close the BOP, why the BOP failed? Okay, because of buckling of drill pipe, it got off-centered and we were not able to close the well. And now we have seen types of balances, overbalanced, underbalanced, unbalanced, and types of pressures. Okay, guys, 1 minute, huh?
So there is a question in the chat box.
Okay, so this we have seen. Okay, so we will discuss about influx. Okay, influx is entry of formation fluid in the
Sir, you can continue here.
Okay. Yes, so there is a good question from Shiksha that how many days does it take to control the well? Okay, so there is no time limit for that. Okay, it can take any days. Okay, it can be now like when I was on rig. Okay, when I was on rig, it took 8 days. There was no blowout. Okay, there was no blowout, but there was a kick. Formation fluid has entered the wellbore. Okay, there was no kick, so it took 8 days for us to control the well. Okay, so there is no time limit, and if they plan to drill a relief well, okay, then it's all depending upon the situation. So there is no number of days fixed for this. Okay. So let us discuss about influx. Okay, so let us discuss about influx. What is influx? Influx is nothing but entry of formation fluid. Influx is nothing but entry of formation fluid in the wellbore. So when hydrostatic pressure goes below formation pressure. When hydrostatic pressure goes below formation pressure, there is a kick and formation fluid enters the wellbore. Okay. So when the formation fluid enters the wellbore, we go for secondary well control. That is, we use BOP. Okay. And we try to close annular BOP first, because annular BOP can be closed on any size of tubular. Okay, so BOP is your secondary well control and primary well control is your mud. Okay, so now we'll see causes of kick. Okay, we'll see causes of kick. Okay, so kick is nothing but influx. Kick is nothing but influx. So what is influx? Influx is entry of formation fluid into wellbore. Okay, so primary well control is described as hydrostatic pressure is greater than equal to pressure. So if you have primary well control, then there are only two ways. Then there are only two ways where just let me mute the Ayush. Okay. So if you have primary well control, then there are only two ways you can lose. Your hydrostatic pressure can drop or your formation pressure has suddenly increased. Okay, these are the only two ways where you can lose your primary well control. Now there are a number of reasons why your hydrostatic pressure will drop, and there is only one or two reasons where your formation pressure will suddenly increase. That is, you detect abnormal pressure zone or there is a trapped pressure zone. Okay, so what are the reasons your hydrostatic pressure will decrease? Number one, failure to fill hole properly while tripping. Okay, failure to fill hole properly while tripping. Now, what is tripping operation? Tripping is you're removing pipe out of the hole or you're going in the hole. Level of water will increase. Okay, if man jumps in the pool, level of water will increase, and if that man goes out of the pool, then the level of water will decrease. Okay, so similarly, if you remove the pipe out of the hole, if you remove the pipe out of the hole, what will happen? The level of mud will decrease. And if your mud height will decrease, we know that pressure is directly proportional to the height of mud. So if your mud height will decrease, then what will happen? Your hydrostatic pressure will decrease, and if hydrostatic pressure goes below formation pressure, if hydrostatic pressure goes below formation pressure, then what will happen? There will be a kick. Okay, so this is one reason. So what driller should do? As soon as they are removing pipe out of the hole, driller should try to fill, driller should try to maintain the level, driller should try to maintain the height of mud inside the well. Then we have swabbing. What is swabbing? Swabbing is if you're pulling out very fast, if you're pulling out, okay, if you're removing pipe out of hole very fast, vacuum is created at the bottom of the drill string, and it will suck formation fluid in the wellbore. Okay, so that is called as swabbing. That is while if you remove your pipe very fast, okay, swabbing takes place. Lost circulation. If you're losing mud in the formation, okay. Now, as I told you that if you encounter subnormal pressure zone, if you encounter subnormal pressure zone, what will happen? You will lose your there is a possibility that you can lose your mud in the formation. And if you're losing your mud in the formation, what is happening? The level of mud in the well is decreasing, and if it goes below formation pressure, then the formation fluid can enter wellbore. Okay, and insufficient mud weight. Now, suppose you do not maintain your proper mud weight, you add more and more water, or you are not mixing your mud properly, okay, by agitators, okay, and if your agitators are not operating, then what is happening? The barite in the pit will settle down and your mud weight will decrease. Okay, so these are the few reasons where your hydrostatic pressure can decrease. Okay. Now, okay, now your hydrostatic pressure is going below formation pressure, okay, or your hydrostatic pressure is getting equal to formation pressure. Guys, I have already told you that you have to always maintain hydrostatic pressure greater than formation pressure, okay, but because of few mistakes, human errors, okay, there is a possibility that your hydrostatic pressure will get equal to formation pressure or it will go below formation pressure. Now, kick warning signs. Okay, so what is kick warning sign? A kick warning sign is a well telling you that the bottom hole pressure and formation pressure are getting closer together. Okay, see, hydrostatic pressure is always above formation pressure. Okay, but due to some reasons, there is a possibility that hydrostatic pressure and formation pressure are getting closer. Okay, so that you will get some indications, you will get some signs at the surface, and that is called as kick warning sign. Kick warning sign is telling you that your hydrostatic pressure and formation pressure are getting closer. Okay, so what are these warning signs? These warning signs are increase in drilling rate, increase in gas trend. Okay, you are getting more and more gas at the surface, change in cutting size and shape, temperature measurement, increase in torque and drag, decrease in shale density, change in D exponent and chloride trends. Okay, increase in drilling rate. Okay, you will see that your drilling rate has suddenly increased. So this is one of the kick warning sign. Increase in gas trend. Your mud logger is telling you that more and more gas is entering the wellbore. Change in cutting size and shape. The driller, the shaker man will see that the cutting size are big and large. Temperature measurements. Formation temperature will increase. Increase in torque and drag. Driller will notice that the torque force or the drag force has suddenly increased. Okay, so these are the few kick warning sign. Okay, so whenever there is a kick warning sign, driller should stop drilling. Driller should stop drilling immediately and consult with the supervisor. Okay. So these are the kick warning sign. Driller should not close the well in kick warning sign. But if there are kick indicators, indicators, driller should immediately shut in the well using BOP. Okay, so driller should first close annular BOP. Now, what are the kick indicators? Kick indicators are increase in return flow rate. Okay. Now, if driller notices that the mud which is flowing out of the well through annulus, suddenly if driller notices that the flow rate has increased, okay, it means it is kick. It's a kick sign. Okay. Increase in pit volume. Okay. Increase in pit volume. Okay. So if somebody informs driller that, okay, the pit volume has suddenly increased by 10 barrels, it is kick indicator. Variation in pump speed and pressure. Okay, so if the driller notices that the pump speed has increased and pump pressure has decreased, okay, it is kick warning sign. And well flow during connection. Okay, so if well is flowing during connection means your pumps are off. Okay, pumps are off and the well is flowing. Okay, so like if you're not pressing the accelerator in car and still the car is moving, it means somebody is pushing your car. So similarly here, your pumps are off and if you still see well is flowing, it's a kick indicator. Okay, so whenever there is a kick indicator, okay, what are the steps that driller should follow? Driller should immediately stop drilling. Okay, stop drilling, stop pumps, stop rotation, and close annular BOP. Okay, so these so guys, after any of the kick indicator, okay, any of the kick indicator like increase in return flow rate and well flow during connection, driller should shut in the well using different shut-in procedures like soft shut-in procedure, hard shut-in procedure, which we won't be able to discuss today because of time limitation. Okay, we won't be able to discuss that. So there are lots of topics in well control. Usually it is for 5 days. Okay, so this was the introduction class. Okay, so if anyone has any questions, what is this? Waiting on participants. Okay, so anybody has any questions, guys? You can just send me a message in chat box. There are lots of topic, but I won't be able to cover it today. What is D exponent? Okay, so as I said that, okay, so whenever there is a kick warning sign, the drilling rate increases, rate of penetration increases. Okay, so driller will notice when we are plotting a graph of depth versus time, when we are plotting up the graph of depth versus time, okay, their driller will see a change in graphical representation that is called as D exponent. D exponent, yes. So why do we see that the rate of penetration has increased? So rate of penetration increases because in abnormal pressure zone, shale density decreases. Okay. If shale density decreases, the rate of penetration increases. Okay. So that is the reason we see that ROP has increased. So whenever the ROP increases suddenly, it is one of the kick warning signs. Sir, how the temperature decrease? Okay, which temperature? It's a formation. So, if abnormal pressure zone, in abnormal pressure zone, it has high pressure, high temperature formation. Okay, it's a high pressure, high temperature formation. Okay, so if we notice, we have many LWD and MWD tools. Okay, they measure the formation, pressure, and temperature. So if the formation temperature increases, we will get notified. How the formation, Himanshu, what is your question? How the formation pressure decreases? Formation temperature decreases. Any more questions, guys?
I think that's it.
So guys,
Thank you, sir.
yeah, thank you so much, guys. I hope you understood whatever we have discussed today. I know it was a short presentation. Okay. Maybe some other time we can do 1 or 2 days. Actually, I wanted to show you some software also, but maybe next time I'll discuss with Anshu or Devraj. Okay, I'll show you the practical aspects of well control very soon. No, during kick indication, formation temperature increases, Himanshu. Kick warning sign, formation temperature increases. So that is one of the kick warning sign. Okay. All right, Anshu.
Yes, sir. Thank you, sir. I am sure everyone has gained knowledge from this. We have attended a lot of webinars but never encountered the concept related to well control. This will be of great help of us towards our journey of becoming a petroleum engineer. Thank you, sir.
Thank you.
Thank you, sir.
So we consider ourselves immensely lucky today that we got to interact with you. The insight you provided us with about well control at such an early stage of our engineering journey is truly eye-opening. We all thank you for your guidance again, sir. Hope every student has enjoyed and learned something new today. Thank you for joining us today, sir. Surely we will follow the things you have said. Thank you, sir.
Okay, guys. Thank you so much. Best of luck for your career. Bye.
Bye, sir.
Bye, sir.
Bye.